Okay, I've been talking about the dilatometer tests, which are linear expansion tests. So what happens is we take a bar of glaze or bar of clay, a bar of bisque that's cut in 2-inch section, and it's put inside of a chamber that is tested with a dilatometer. It's a very expensive instrument that Orton does for us, and it measures the expansion or the volume of the size of the clay or the glaze as the temperature rises. An interesting thing happens at around 600 degrees Celsius, and I'll get into that in a little bit. Right here, this is glaze. This is a glaze linear expansion model, and as you can see, it's heated up, and as it heats up, this is the linear change, the percent linear change. This is your temperature. So as your temperature rises, so does your specimen or the product that's inside of the dilatometer. Everything expands with heat, most everything, but in ceramics it will expand. And so as it expands, it gets to a certain level, which is around, in this case, around 600 degrees Celsius. It goes through this change. It's around 560. It goes through a change, and it goes through a large linear change, where the large volume change, where the glaze expands rapidly, and then it gets to a point and then it just drops off. And this is actually the melting temperature. This is where your glaze melts and it becomes a liquid. Therefore, you cannot measure it anymore, and so it drops off, and there's no more chart. This is an example of a Bisque linear expansion test, where you have again your percent linear change and your temperature. And as you can see, as the temperature rises over here, it increases in volume, and you get to a certain point right here, and this is called people call it a shoulder. It's called your phase transition, and that's where your silica that's in the body of your bisque will go through a change. It's a big volume change, and what we have found is we've had much more success with a smaller shoulder on our bisque than in other bisque that we've tested has not so a more drastic change. In other words, what's happening here is that the volume of the bisque, the size of the bisque, is growing around the same temperature as also the glaze that I just previously showed you went through a large change. I'm going to show you this is a really nice smooth transition. This is a nice shoulder right here. It's very small. It's not so drastic. Here's another one that's really nice. This is a nice change. As you can see, I don't know if you can tell the difference here, but right here and right here, this is not so good. You have a really large change in volume, and what that's gonna cause some problems, and I'll show you later how that can cause problems. I'll show you. This is the bad. So we have the good, the bad, and this is the ugly. This is just, and by the way, this is available in the marketplace right now. Not by Bisque Imports though. But what happens is you have this huge shoulder here, and this can cause all kinds of problems with shivering or crazing. It's just a real drastic, it's a sporadic kind of a crazy clay that's not going to mate very well with your glaze. And over a period of time, it could be months or years down the road, you're going to see crazing on that body. Okay, and here's another one that's not so good. You got a really strange shoulder here. Not good. All right, so what does all that mean? Well, let's plot it all together. So if you have your glaze, then you have your bisque expansion rate. If you plot it all together, you kind of get an idea of what we're doing here. As you can see, these are the glaze. There's 3 glaze plots here. This one right here is a leaded glaze, has lead in it. This is an unleaded glaze, non-toxic glaze. As you can see, the non-toxic glaze has a higher melting point, and what that means is that it's going to melt at a higher temperature. That causes problems if your bisque is not mated properly with your if your glaze is not mated properly with your bisque body, if your bisque body is going through all kinds of changes with a non-toxic glaze that sets up at a higher rate, then, for example, what's going to happen is as the kiln is cooling and it's cooling down, your glaze is going to set up. And with non-toxic glazes, your glaze sets up quicker. And as the kiln continues to cool down, you'll see that the glaze is just getting to its final stages of where it wants to be for the rest of its life. And then you have your bisque that changes drastically, like a 5% change. You want this shoulder to be as small as possible to reduce the amount of stress that you're going to have on your glaze. You can see right here, this non-leaded glaze has no problem. So this right here is a very tenuous spot. And if you have a bisque body that is not, that has a very large change, something of this sort, if you plotted this with this glaze, you're not going to get a good mate. They're not going to be bonded well. You're going to have a lot of stress. So that's what linear expansion is all about, and I just felt like maybe a little bit more explanation of why we test linear expansion. It's just one portion of all of our testing, but it gives you insight as to how it's going to mate with your glaze. Thank you.